लैपटॉप चालू ही नहीं हो रहा। लैपटॉप चालू ही नहीं हो रहा।
So let's begin. Right. So what is the sum of all the angles of a triangle? What's the total of it?
180.
180. That's perfect. 180 is the sum total of all the angles of a triangle. Now, let's try out one question. So, we are having a triangle PQR. PQR. Okay. This is angle P, angle Q, and angle R. So the measure of angle P is 30 degrees, angle Q is 45 degrees. Okay. Question is, if in triangle PQR, angle P equals
Ma'am,
to 30.
do we need to draw the literal measurements?
Hmm. We have to draw the literal measurements. And angle Q, 45 degrees. Then find the measure of angle R. Find the measure of angle R. Try this out and let me know the answer. What you are talking.
Ma'am, is the answer 105 angle R?
Yes, answer is 105. Hope everyone is getting 105. Angle P plus angle Q plus angle R. Sum is 180 degrees. We know that angle P is 30 degrees plus angle Q is 45 degrees plus angle R we don't know 150. Okay, so we can sum 30 and 45. 75 degrees plus angle R equals to 1. So angle R equals to 180 degrees minus 75 degrees. 105. So this question is clear to you guys?
Yes.
Yes, ma'am. Just give me a minute. I'm writing it down.
Okay. Abraham, hope it's clear.
Yes, ma'am.
Okay.
Done, ma'am. Thank you.
Alright. Now, let's do one more question. So sometimes what may happen that you will not be given the exact measurement, okay, of the angles, and instead of that, ratio might be there in the question, like this question. How do we solve that when ratio is given, not the exact measure, not the number, but the ratio is given. Ratio of the angles, ratio of the angles of the triangle of a triangle is 1 is to 2 is to 3. Find the measure of the three angles. One, of the three. Okay. Now we will assume that
Is it
the ratio we
the
have
first one? Is the first one 30 degrees?
is the first one 30 degree. Yes, and the first one is 30 degree. Very good. So we will assume that 1 is to 2 is to 3. We can take them as x. Okay. 1x plus 2x plus 3. Okay. Because the values we don't know, so we can put x. So the sum will become 1x
Because I thought it is like you can divide it by 1 plus 2 plus 3 because it is to that much of the ratio.
yes, yes, that's right, Sandra. Okay. 1 that is x plus 2x plus 3x is equals to 180. Okay. And the total of the ratio, like Simeon said, it comes 6x equals to 180, or you can just do 6 equals to 180. X equals to 180 by 6. You can divide it. Okay. 6 ones are 6 threes are 18 and 0 equals to 30 degree. So we have x which is 30 degree. Now ratio is 1 is to 2 is to 3, or 1x is to 2x is to 3x. X we know is 30. What will be the second angle? 2x means x into 2. So this is first angle, first angle. Okay. For the second angle, we can do second angle. We can do,
Second angle would be 30 to 2, right?
yes, 2x means 30 into 2 or 2 into 30, which is equals to 60 degrees. Similarly, with the third angle, very same is 3x means x is 30. So 30 into 3 will be the third angle. Third angle is 3x. So
Will it be
30,
90?
yes, it will be 90 degrees. Okay, so the measures are 30 degree, 60 degree, and 90 degree. Hope this question is clear.
I'm just writing it down. It's fine.
Yes.
Okay. Okay. So when it comes in the ratio form, you have to solve it like this. Okay. Take the total of it and divide it by 180. You get the first angle. And then keep doing according to the ratio of the other angles. Just multiply the first x value of x we have. So multiply that with the number of the ratio number given. So you will get the measure.
Done, ma'am.
Okay. Written Abraham, I'm going to clear it.
Yes, ma'am, you can clear it.
All right. So one question I am going to give you all. Okay, one question I'm going to give you all. You just try it out and let me know. All the three angles of which triangle are equal. Find the measure of each of the angles.
Ma'am, 60.
Yes, 60. Very good. Because they are all equal and sum is 180. 180 we can divide by 3 and we get 60 degrees. Okay. So all angles will measure 60 degrees. Okay. Done, guys.
Yes.
Yes, ma'am.
Okay. Now we are going to do a concept that is the relation between exterior angle and interior opposite angles. Relation between the exterior angle interior opposite angles. This is again a verification. Okay, so let's draw the figure. Draw a triangle ABC. Angle 1, 2, 3, and 4. Okay, so if you extend BC, okay, of triangle ABC to point P, you will get the exterior angle ACT. Okay, ACT exterior angle we will make. All right. So, in triangle ABC, in triangle ABC, angle ACT is the exterior angle. Exterior. Okay. Now, what is the sum of all the interior angles of a triangle? Angle 1, 2, and 3, 180. So we can write angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay, that is sum of three angles of the triangle. Three angles of the triangle. Okay. And we can also write that angle 3 plus angle 4 will be 180 degrees. Look here, angle 3 means this one, and angle 4 means this one. Will be 180 because they are linear pair. Okay, we know that its sum will be 180 degrees. So we can write that angle 3 plus angle 4 will be 180 degrees. Why? Because it's linear pair. Now, this is the first equation. This is the first equation. This is
So what are you supposed to find in this?
second equation. What are we supposed to find? we are supposed to verify to find that the sum of interior opposite angles is equal to the exterior angle. Means the sum of angle 1 plus angle 2, its total will be equal to angle 4. This we are trying to prove. Okay, this we are trying to prove. Now, equation 1 and 2 we have. Okay, and we'll write them together. That is angle 1 plus angle 2 plus angle 3 equals to angle 3 plus angle 4. So angle 3 is common in both of them. We can cancel it. So we will have angle 1 plus angle 2 equals to angle 4. Okay. See, angle 1 plus angle 2 plus angle 3, the sum is how much? The sum is 180. Then angle 3 plus 4, the sum is also 180. That is why we wrote that angle 1 plus 2 plus 3 equals to angle 3 plus angle 4. That is why we wrote it like that, putting an equal to sign. Then angle 3 and angle 3 we cancel, so we will left with angle 1 plus angle 2 will be equal to angle 4. Therefore, we know that, therefore, exterior angle of a triangle, exterior angle of a triangle will is equal to sum of interior opposite angles. Sum of interior opposite angles. So hope this verification part is clear how the interior opposite angles and the exterior angle are equal. Any doubt, anyone?
I didn't hear the last part.
You didn't got the last part. Okay, I'll explain you. See,
No, the
angle
last part of
1,
what you said, of what you asked.
what I asked, I said, um, are there any doubts in the verification part?
Not
The last part I said that angle 1 plus 2 will be equal to angle 4. Okay? And therefore, the exterior angle of a triangle, that is angle 4, will be equal to angle 1 and angle 2. Okay? Abraham, hope it's clear. We want me to explain again. Okay. Okay. Anaya, clear? Okay. Yes. So this was the verification. Now let's try out some questions on it. Okay. Let's try out some questions on it. I'm clearing the screen. I have a triangle ABC. Okay. Now, this is 70 degree, angle A, 70 degree, angle B is 80 degree. Question is, find the measure of angle ACT. Find the measure of angle ACT. The question is on this verification website. Yes, the question is on the verification we just did.
Ma'am, C equals to 30 and D equals to, does C equal to 30?
Is C equals to 30. The inside part, this one,
Yes.
yes, it's equals to 30. But what is the measure of this one? Outside one.
Then if C equals to 30, then D will equal to 150.
150, yes, that is right. Okay, that is one method. Another method that we can do, both are head-on. Okay, you did first found out the interior angle, then did the linear pair method. That is angle ACP plus ACD equals to 180. When ACB is 30, ACD is 180 minus 30, 150. Okay, and there is one more method, that is angle ACT that you have to find out is equals to angle BAC plus angle ABC. ABC means angle A plus angle B, because the sum of interior angles equals to the exterior angle. So angle ACD equals to 80 degree plus 70 degree. Okay. Angle ACD equals to 150. Okay. This is one method. All right. Alliance method was also correct. That is the linear pair method. Okay. I'm writing that one also. Angle A plus angle A plus angle C. Okay. So 70 plus 80 plus angle C. 180. So angle C equals to 180 degree minus 50 degree that is 30 degree. Then angle ACD plus angle ACB is also 180 because linear pair. So angle ACD we don't know. It will, but ACB is 30 degree equals to 180. So ACD equals to 180 minus 30 minus 70, that is 152. Okay. Any doubts, anyone? Till
No,
here? No?
no doubt.
Okay. Abraham, if it's clear to you, can you hear me?
Yes.
Okay. All right. So the weekend you guys are having, in the weekend, please try out exercises 12.1 to 12.3. Okay? Very small exercises are there.
To 12.2 or 3, ma'am, you said?
12.1 to 12.3, right?
Yes, 12.1 to 12.3. Only two, three questions in every exercise is there. Very small exercises are there. Okay. 12.2 and 12.3 only three questions are there. And 12.1 I think is only fill in the blanks. Four questions are there. So very short exercises. Please try this out in the weekend. Okay. And test of math chapter I think 11th chapter, right? Yes. Maths chapter 11. 10 we took the test. 11th chapter test of maths on Tuesday. Okay. Maths chapter 11 test on Tuesday.
Chapter 11.
Yes.
And what about science next week, ma'am?
Science I'll let you know. Okay.
Okay, but maths test is on Tuesday.
Maths test is on Tuesday.
Okay.
Science test will probably be Thursday or Friday. Okay. Probably Thursday
Um,
or Friday.
this chapter 11, which one is it?
Which one is it? Lines and angles. The
Okay.
previous chapter that we were doing, that big lengthy chapter about lines and angles. Okay, that one. All right, so we will stop the math class here and 5 minutes break, and then I'll see you in the science class. Okay, hope you all are ready. Yes, we are going to begin the class. It is on, please. Abraham, you. Hope you guys are there. Please turn on the video. So today we are going to start with a new chapter that is sound. Okay. Now, there are various types of sounds that we hear in our day-to-day life. Okay. We keep hearing maybe sorts of sounds. Yes, Emma. It's okay. Yeah. So suppose the sound of the wind, okay, the sound of rustling of leaves, the sound when somebody around us is talking or when somebody is speaking to us, that is sound of their voice. When we are speaking, sound of our voice. Right now you are listening to my voice when I'm teaching. Yes, so the sound of that. So various sounds are there that we listen to in our daily life. This is what that this chapter is about. We are going to do the definition of sound, its characteristics and nature, and how sound travels. Okay, how sound travels, and about the listening process in humans, how it reaches us, okay? And then how sound is produced. Okay, and how noise pollution is caused, how noise pollution is there, and how we can save ourselves from the noise pollution. Okay, so we are going to study about all of that. Now, what is sound? First, sound is an important form of energy. So it connects us to the environment and let us know the changes that takes place in the environment. We learn what is happening around us by sound, by listening doorbell, by thumping on door, and we know that someone has come to meet us. So it tells us about various changes that are taking place around us, that are taking place in the environment around us. Okay? And sometimes, even if we are not looking, we get to know various things just by listening. Okay, just by listening. That when we hear footsteps, we know that somebody has gone, even though we have not seen them. We listen to the doorbell or knocking on the door, we know that someone has arrived, even though we have not seen them. Okay, we are in some other room, but we know that someone has arrived because we heard the sound of the doorbell, we heard the knocking on the door. So sound helps us to know about the changes that are taking place around us, what's happening around our environment. Okay? So this is a little activity you can try out after class. Prepare a list of sound around you, and you will know the major changes around. Okay. You can prepare a list of 3 to 4 sounds that you hear without looking, and you will know that how only by listening you can tell that some changes taking place around you. Okay. Now, this is another activity. Take a metal utensil, hang it in such a way that it does not touch a wall. Now hit it by a stick. Touch your finger after hitting. Do you experience any vibration? This is about vibration. So, items producing vibration produces sound. This is seen in some situations. It is difficult to see this vibration in most of the situations. The reason behind this is that we cannot see vibration by our eyes. So sound is produced through vibration. Okay. like when the vibration is happening in something. What is a vibration? Um, a small, slight, shaky movement of something. Okay? If it is a
I
lesser
didn't hear the
vibration.
last part.
You didn't hear the last part. Okay. The shaking movement, that is to and fro movement of something that happens very quickly, and it vibrates. So that movement of the shaky movement to and fro movement of something that causes or produces sound. Okay, that produces sound, and we cannot see the vibration. We can feel the vibration if we touch a vibrating thing. We can
But you
feel
could
the
also
vibration.
see the vibration if you could see the thing shaking, right?
If you could see the things shaking, yes, some things that have strong vibration, we can see the vibration. Okay, that have strong vibration, we can see, but very minute vibrations we cannot see. Okay, so due to that vibration, sound is produced. In reality, every source of sound is a vibration doing thing or an item. Every source of sound is a vibration doing thing or an item. Means the thing that is producing a sound is actually in vibration. All right. Now, when an item moves to and fro from the center, it is known as pendulum or oscillation. Okay. To and fro. Can you see the pendulum on the left, on the right, and then on the left, then on the right? That is to and fro motion from the center. Okay. And this is how the vibration also works. The to and fro motion that happens really quickly. It happens really quickly. Okay. And that is how vibration basically takes place. This is an activity for that. 16.1, try it out, please. Okay. Then sound produced by humans. You know that humans produce sound with the help of their throat. You keep your hand in your throat, you will find a hard bump. When you eat or drink something, this body part moves. This is known as vocal cords. We all know that our voice is produced by our throat. The voice box is present in our throat. Okay. And when we are eating or drinking, it moves and it is known as vocal cord. These vocal cords are on the upper end of the breathing pipe. Upper end on the breathing pipe. Vocal cords are two voice boxes which have a narrow passage.
So that is the larynx, right?
Right. Okay. The muscles related to vocal cords can make cords tight and loose. So the vibration is also taking place in our vocal cords while we speak. Try placing your hand on your voice box, okay, the lump in your neck, and try speaking something. You will feel that you will be able to feel that slight vibration. If you want to try it right now, okay, put your hand on the white box and try saying something. Try to say, speak something. You will feel that vibration, okay, and the vibration that is taking place there in the voice box in the vocal cords is producing sound. Okay, that is producing sound. Muscles related to vocal cords can make cords tight and loose. When lungs forcefully push the air out, then vocal cords get vibrated and produce sound. Sound is different in both loose and tight cords.
In the diagram, the is the pink thing the vocal cord? The pink thing in between those two brown things.
This one,
Yeah.
yes, it is a vocal cord. This is the breathing pipe. This is the neck, and this is the jaw.
What is the brown thing?
This brown thing, this one,
Yes.
it is the muscle that's joining your neck part. Like the muscle below the jaw part. Okay, all right, it's the muscle, and inside that there is your windpipe, food pipe. Okay, which is connected to the vocal cords, voice box. All right. Yeah. Now, do you know that the length of vocal cords is in males is around 22 millimeter and females have 15 millimeter vocal cords. The difference of male and female vocal cord is 5 millimeter. Children have small vocal cords, smaller vocal cord. Therefore, the sound of women, men, and children are different from each other. Okay. Um, Basically, the difference in voices is because the different lengths of the vocal cord and different vibrations that's taking place. So, there different lengths and different size of the vocal cords. Okay. Therefore, the men have very deep voice, heavy voice, but the females have softer voices compared to them. And children have very soft voices because they have small vocal cords. Then, how sound travels. Now, when sound source starts the vibration, then the molecules of air also vibrate. These make other elements present in them also vibrate, and this way process goes on. The sound then reaches from one place to another by means of air. Therefore, we know that sound needs a medium to move. Sound moves in all three mediums, solid, liquid, and gas. Sound needs a medium to move. Okay, either it can be air, okay, or water. All right, all three, that is solid, liquid, and gas. Okay, they work as a medium. Now, when we are speaking, okay,
Sound
our
transmit,
voice,
I mean, solids transmit sound best, right?
solid transmits sound best. Yes, we can say that. Okay. Um, I want to show you all a diagram. Just give me one minute. These are the three mediums that sound travels in: solids, liquid, and gases. Okay. And sound travels best in the solid. Okay. Fastest in
Because
the
there is
solid.
more vibration then. Okay?
Yes, that is right. Okay. And in liquids, little less faster than solid, but in gas, um, even less. Okay, like the fastest in the solid, faster in liquid, and in gas, fast. Okay, but where there is no medium, no sound can be transmitted. Where there is no medium, then the sound cannot travel. Okay, all right. So when sound is traveling, okay, vibration is also taking place, this which again causes the vibration Um, in the medium, it is traveling through. Okay, that is the vibration and travels through the solids. Okay, the vibration starts taking place in the molecules of solid. Okay, in the molecules present in the solid, and then through that it will reach the um where it needs to travel. Okay, then listening the sound. We already know that sound is produced by vibrating object and they can be sent in any direction and any medium, means solid, liquid, or gas. But how do we hear a sound? How do sounds are listened? How do we hear a sound? We know that we hear by our ears. The outer shape of our ear is like a key. Sound then moves in a pipe after entering the outer ear. This pipe has a thin layer known as eardrum. Eardrum is an important part. What are the functions of eardrum? This is the structure of an ear. Okay, this is the outer part of the ear. This is the middle part. This is the middle part, and this is the inside part of the ear. This activity we are not doing right now. Just 1 second. This is the process of hearing the sounds or listening to the sounds. Basically, when an object it produces the sound, okay, we know that it travels in the form of sound waves in the through the medium, okay, be it solid, liquid, gas, it travels in the form of sound waves, and then it travels to the air and are collected by the pinna or our outer ear, okay, or our outer ear, and funneled into the ear canal. Funneled into the ear canal, that is, it goes inside our ear and it
It
reaches
almost sounds like a Rube Goldberg device.
like a what?
A Rube Goldberg where one thing will hit another thing and then it will perform a task.
When one thing will hit another thing and it will perform a task. Yes, it is kinda like that. Okay, and eardrum vibrates. The sound waves cause the eardrum to vibrate, and it is very sensitive and can detect even the faintest sounds. Then oscills amplify vibration. The vibrations from the eardrum are sent to three tiny bones in the middle ear called the malleus, incus, and stapes. These bones amplify the vibration and send them to the cochlea in the inner ear. Then cochlea fluid ripples. The vibration caused in the fluid causes it to ripple, which stimulates hair cells that sit on the top of the bacillate membrane. Hair cells send messages to the auditory nerve, which carries the signal to the brain. Okay, and then brain receives the signal and translates them into the sound we can understand. This is the whole process of listening, but it happens very quickly. Okay, why? Because sound waves are very fast. They travel in a very fast speed, and then the process that is going on, the hearing process, also happens very quickly. Like as soon sound waves they travel very fast and it just reaches the ear and then goes inside and the eardrum vibrates. Okay, then vibrations are amplified, which causes ripples in the fluid, and then the hair cells send message to the auditory nerve, It signals the brain and then brain intercepts the message. Okay, and translates the message. So this is the whole process. It happens within very short time. Okay, within seconds it happens. This process happens within seconds. Okay, and this is the diagram of the ear. Okay, this is the outside part. Then this is the ear canal. This is the ear canal.
Oh,
This is
can you show which is the malleus and incus and stapes?
yes, here. Malleus and incus and stapes are present here. Here, okay, and eardrum. Vibration of eardrum then leads to this. Then this is the auditory nerve. These are also semicircular
That pipe thing
canals.
is the nerve, right?
This pipe thing is the nerve. Okay, this goes to the, this is connects with the brain. Okay, this takes the signal to the brain and then the brain intercepts the message, translates the message in a form that we can understand. Okay, this is the diagram of ear. Please, you have to do this diagram of ear. Okay, you have
Mom, could you
to,
please send the diagrams of each chapter once the chapter is finished?
yes,
Or like each chapter
yeah,
or each diagram, you keep doing this as you would do earlier in the group. Will you send
mhm,
them, make a PDF
yes,
and
yes,
send them?
yes, yes. I'll make a PDF and I'll send it. Okay. Yeah, for tests also for your practice, I'll send the diagrams. Okay. Now, identifying various types of sounds. We identify sound easily without seeing them. We identify the object. However, this is possible when there is some difference in all the sounds. Dimension and frequency are two important characteristics of sound. Dimension and frequency. Okay. Only how do we differentiate the sounds? How do we differentiate the sounds from the other sound? That difference is on the basis of its dimension and frequency. What is dimension and frequency? Okay, this means hit a drum slowly and then beat it fast. Do you realize when dimension is maximum, when sound is loudest? This means when here is maximum dimension of vibration, then sound is maximum of dimension. When they are small, then sound is less. So, dimensions is what basically it depends on vibration. If something is vibrating slow, the sound will be of lesser dimension. But if something is vibrating very fast or hard, the dimension will be much more. Okay, so the vibration that's taking place, lesser or more, and due to that, the sound is being produced as lesser or more. We can identify, we can differentiate in that. Okay, and then what is the measuring unit of sound? It is decibel, dB. Okay, sound is measured in dB, decibel, and this is the frequency of various types of sounds. Okay, very various types of sounds. Normal breathing, 10 decibel. Okay, means very less sound. Whispering is 30 decibel. Okay, and normal conversation, talking, we do in 60 decibel. Busy traffic is 70 decibel. Average factory noises in a factory is 80 decibel. Okay, but sound over 80 decibel is very painful and is considered as noise. Now, what is basically the frequency? the number of times a sound wave repeats itself per second. Okay, the number of times a sound wave repeats itself per second is basically the frequency. Okay, this is in 1 second a sound wave. Well, this is another sound wave in 1 second. Can you see the difference?
So the second one is louder.
Yes. Okay. But the second one will be louder in more higher frequency it will have basically. Okay, it will have higher frequency. All right, first one will have lesser frequency because the number of times the sound wave repeats itself in a second. Okay, that is its frequency. Normal breathing 10 decibel means I explained this, yes. Soft and average factor 80 means loud, and above this is considered painful and is considered noise. Okay? Compare the voice of a child and adult. Do you find any difference? Do you find both of them equal or different? Let us see how these are different from each other. An activity: put a rubber band on the head of a nail. Keep the other end in your left hand. Make it vibrate by right hand. Listen to the sound created. Pull rubber band and make it straight. Make it vibrate and listen to the sound. Which stage has maximum sound? By stress increasing in number, the frequency of vibration also increases. It has a more loud sound. This characteristic of sound is loudness. Voice of girls has more loudness than the voice of boys. The characteristic of sound which helps us in identifying voices is known as timbre. Three characteristics of loudness, frequency, and timbre helps us in identifying these. Okay, so this is based on the tension created in the voice, the tension there is in the voice. Okay, if there is more of it, then the vibrations taking place will be much more and sound will be louder. Okay, you can try this rubber band experiment today and find out. All right. So there are three
I've done it
characteristics.
before, but it's not louder. It's only more high pitched.
High pitch, yes.
Can we use a guitar instead?
Can you use a guitar instead? You can use a guitar instead if you play it slow and then play it harder. If you pluck on it slow and then you pluck on it harder, that way you can try out with a guitar. Okay. The vibration also you can check with the guitar. Vibration of the strings. Okay. And so the three characteristics of sound are its loudness, frequency, and timbre. Okay. They help us identify or differentiate between various types of audible and non-audible sounds. Every object that vibrates produces a sound, but not every sound we can listen to. These sounds, which can be heard by humans, are called audible. Which can be heard by humans are called audible. And we cannot listen to a frequency less than 20 hertz sounds, less than 20 hertz sounds. If you are breathing normally, okay, normally, can we hear somebody breathe normal breathing? I'm not talking about a fast breathing, okay, or a heavy breathing. I'm not talking about that.
You
A
can
normal breathing.
put your ear to their nose.
You can hear their through their nose,
Hmm.
the breathing at its pace. If you're very close to someone, if you're sitting very close to someone, and they're breathing slightly heavier, only slightly than normal, then you can hear. But if you are sitting with someone, with people in the room, you cannot hear the breathing sound of everybody. Normal breathing you cannot. Stress breathing you can hear.
And if you
Breathing
have
that,
a, then you can hear like a stethoscope.
yes, then you can hear because that device, with the device you can hear that. And also, if someone is breathing heavily, then you can hear that sound. Then increases more than 10 hertz. Okay, breathing is 10 hertz. Okay, but if breathing goes to 20 hertz, that is when someone is breathing heavily, loudly, then we can hear them. So our hearing capacity, our hearing ability starts from voices that are 20 hertz. Okay, that our ear can pick up. That is audible sounds to us. Okay, those sounds are audible to us. But below that are inaudible sounds. Okay, non-audible sounds. So human ear can listen to a sound from 20 hertz to 20,000 hertz. Do you know that some organisms, like dog, can hear a sound more than 20,000 hertz? Dogs can hear sounds more than 20,000 hertz. Have you ever heard people saying that dog ears are very sharp? Ever heard? People mention, your elders mention that dogs can hear very quickly. Dogs can smell very quickly. You heard that, right? So dogs, why dogs can hear very quickly? It's because their hearing capacity is way more. Okay? You must have seen police dogs. Police uses very high frequency sound whistle for them. Such whistle can be listened by dogs, but not humans. Very high frequency whistle. Okay, because for us that is noise, but for dogs, it's fine. Like for dogs, they can hear it because their hearing frequency is very low. Okay, so we will stop here. Audible and non-audible sounds we did. Okay, and identifying various types of sounds we did. Just give this a read. Okay, diagrams I'll share in the group after the chapter is done. Homework is exercise 16.1. Please complete it in the weekend. Please prepare for the math test. All right, and we will meet now on Monday. Okay. Okay, then see you all. Bye.
Mom,
Okay, ma'am. Thank
when
you.
is,
Bye.
Yes, Abraham.
when is the math test?
When is the math test? On Tuesday.
Okay, ma'am. Thank you.
Okay. See you all.
Bye, ma'am.
Bye. Thank you.
Bye. Bye.